today's webinar. Today's topic is Smart Camera Edge Learning Technology. I'm Luis from Hikrobot technical team. And today's topic will be Smart Camera Edge Learning. To cope with the complexity of industrial inspection, we have developed a series of industrial AI algorithms, including feature engineering, small CNN models, large models of transformer architecture, edge learning, etc. These algorithms have their own advantages and complement each other in applications. As a general machine vision component provider, we are committed to providing partners with more comprehensive and more adaptable products. So these types of algorithms will be integrated into our various intelligent products to provide our partners with rich and powerful application tools. The feature engineering algorithm manually designs feature extractors to extract distinguished features from images, and then use stretch mode or classifiers for classification or identification. Its advantages are simple calculation, relatively mature algorithms, and easy understanding and implementation. Good results can be achieved even in small sample cases. For example, our commonly used template matching, geometric search, and other algorithms have the characteristics of high precision, high efficiency, and high stability in most of scenarios, and are very suitable for applications in high precision positioning, measurement, and other scenarios. However, feature selection and classification require professional knowledge and rich experience, and when faced with complex applications such as tiny scratches and low contrast defects, there are often obvious performance bottlenecks. Deep learning algorithms, commonly known as AI algorithms, can achieve high accuracy detection and recognition by designing deep networks and allowing the algorithm to automatically learn the feature hierarchic in images. They have shown strong capabilities in tasks such as image recognition and defect detection, and can significantly improve the performance of detection tasks and bring through the performance ceiling of algorithms. Therefore, deep learning algorithms have become hot topics in recent years, especially in the field of industrial quality inspection. First, at algorithm level, in view of the characteristics of machine vision applications, we combine deep learning algorithms with feature engineering algorithms to learn from each other. On the other hand, based on the traditional deep learning, we are also focusing on exploring two directions: edge learning for simple tasks and large models for complex tasks. Among them, edge learning algorithm can achieve model updates at the edge through a very small number of images, and are easy to use, low cost, and quickly deployed. As you can see, for the image number requirements on edge learning, it requires only 5 to 10 pieces, but for deep learning part, it requires more than 100. The large model algorithm can adapt to more complex industrial vision tasks with its large parameter scale and powerful representation capabilities. It has good receptiveness and generalization capabilities, and can be quickly migrated to different scenarios and tasks. And for disadvantages, it has high cost of training and deployment. And for the accuracy part, as you can see, for simple tasks, the edge learning is almost similar to the deep learning part, but the sample size will be decreased like 95%, and the training time will be only 1% of the deep learning algorithm requires. Based on these understandings, Hikrobot intelligent product team has provided customers with a series of AI products through continuous innovation in software and hardware, covering Vision Master, Vision Train, AI training platform, AI vision controller, AI training server, smart camera, smart code reader, and many other forms of products. forming a complete set of AI product family and solution from data acquiring, cleaning, labeling, training, edge reasoning, data, and project management. It provides products and solutions for various industries such as 3C, automotive, lithium battery, photovoltaic, medicine, food, beverage, etc., etc. To achieve high precision positioning measurement, code reading, OCR, abnormal judgment, counting, defect detection, and other vision tasks. Here are four classic edge learning algorithm functions. The first one is absence detection. It can determine whether there is a specific target in the scene located and output its coordinate position suitable for flexible objects which change in form. For example, here is a sample for a milk box if the straw is absent or not, and it can detect various behavior. The second algorithm is object counting. It can count and locate targets of single categories suitable for flexible objects with changing shapes. Here is dynamic accounting for goods. And the third algorithm is anomaly judgment. Images can be classified into two categories, OK and NG, based on the registered image categories. Here is a sample for the positive and the negative side of objects. And the last one is classification registration. Images can be classified based on the registered images categories. Supports registering up to 32 categories. It is mainly for distinguish object that has a big difference. Following are some of edge learning cases. The first one is in automotive industrial to see if the nut welding status is correctly. It detects if the nut's direction is correct, and when there are multiple nuts, it will be regarded as NG also. This is the inspection of components in the automotive industry, which requires checking and welding status of nuts at 4 positions by using our smart camera SC3050XC, and also anomaly detection, as you can see here, has 4 positions to be detected, and when there is multiple nuts or the direction is wrong, it will be regarded as NG. The next case is also in automotive and industrial, the identification of wheel hub types. In order to meet different selection requirements in automotive manufacturing plants, different vehicle models are usually selected for mixed production. At the same time, it's necessary to verify the actual selection plan during assembling and the final inspection, and upload the relevant data result to MES system. As you can see in our solution, it detects the types of wheel hub, and it has a great project value. We have an on-site demonstration of testing results which were recognized by customers and included in annual procurement framework agreements. And it promotes the on-site application of GD Auto and cooperate with GD Auto ME to promote it throughout the entire factory area. The next case is in lithium battery industry. The explosion-proof valve positive or negative detection. The explosion-proof valve of the power battery cover plate provides a strong guarantee for reducing the risk of battery explosion and prolonging the rescue window time for a person. Therefore, in actual production, it is necessary to perform forward and reverse testing on the explosion-proof valve of the battery cover plate to avoid reverse installation that may affect its explosion-proof function. We have our project advantages. The first one is we have integrated design of light source camera and algorithm, no additional equipment required. And our smart camera also compatible with multiple SIMs and supports arbitrary switching of SIMs. And it also has multiple communication protocols capable of communicating with POC or third-party interfaces. Now we are going to show some real application live demo. As you can see, this is the interface of our smart camera. Here is the menu bar to set the cameras, set the solutions, and also here is the live runtime interface for the smart camera. And we have, I have already built a solution for the edge learning algorithm named the register object counting. And here I will show how the whole process going. When you open the register object counting tool, the first step will be train the model. It is easy to train model by clicking a register button. And go to camera capture. And capture several images. And then we are going to labeling the captured image by the rectangular tool. And then click register. Okay, now you will see the model is registered successfully. And as you can see, now the object is detected under the live view of the demo. And it shows the actual live value of the counted objects. So this is typical or classic applications by using edge learning tools. Now we switch to another tool. So here is the tool for anomaly detection. I registered several samples and divided into 3 detection zones. And as you can see, this is the OK sample. This is the NG sample. This is also the NG sample. So here, as I registered, here I registered several OK samples and the NG samples, and it can detect very soon. And it can show the difference between, it can show the small difference between OK and NG, as the stripper here is turned on or not. So this is all the content today. Thanks for listening. And any further questions, you can feel free to contact our support team. Thanks.